All right, so before I was gone, we had done some notes on just graphing secant and cosecant, the basic graphs of secant and cosecant. And then today I'm going to show you what to do if you have a variation of secant or cosecant, and you do the same thing for both. Remember, I know it's been a while, but to graph secant and cosecant, you either have to graph the sine or the cosine, depending on are you graphing secant or cosecant. And remember, it's all based on that. So as long as you remember how to graph sine and cosine, it's as long as you can do that, then you can graph secant and cosecant. So the notes are short and sweet today, and then I'll give you your assignment. Okay. So this is called graphing variations of y equals cosecant of x and y equals secant of x. And sorry that you had to, that I gave you review work from going way back from a module or two ago, but I didn't want to try and teach you anything new, especially because I couldn't Zoom into the classroom, and I didn't just want y'all watching, you know, random YouTube videos, so I could only really assign you review stuff, and I wasn't planning to be out, so that's why I went back and did review stuff instead of trying to do something new while I wasn't here. All right, so to graph a secant or cosecant curve, begin by graphing the function where cosecant or secant is replaced by its reciprocal function. For example, to graph y equals 2 times the cosecant of 2x, we would use the graph of y equals 2 times the sine of 2x. Remember, cosecant is the reciprocal of sine. So just replace the word cosecant with sine. Everything else would stay the same. Graph that sine function, and then that'll help you with your asymptotes. Remember, where the graph crosses the x-axis is going to give you your asymptote, and then it'll make sense once we do it, but I know it's been a while. Likewise, to graph y equals -3 times the secant of x divided by 2, we would use the graph of y equals -3 times the cosine of x divided by 2. And then we'll just make a few notes. x-intercepts on a sine or cosine curve will be vertical asymptotes on a secant or cosecant curve. Another note is a maximum point on a sine or cosine curve would be a minimum point on a cosecant or secant curve. And one more note. A minimum point on a sine or cosine curve would correspond to a maximum point on a cosecant or secant curve. Am I still writing that? So if it's a cosecant graph, first start with the graph of sine. If it's a secant graph, first start with the graph of cosine. Okay, you got to remember cosecant goes with sine, secant goes with cosine. All right, can I move on? All right, so we're only doing one example, and I can do more if you need me to. I want you to graph, or we're going to graph rather, y equals 2 times the cosecant of 2x. So if we're graphing cosecant, what trig function do we use to help us graph cosecant? Yes, of course, I need 20, 21. And earlier, the last class I did, everything was January. Not back in the swing yet. So if we're graphing cosecant, what other trig function are we going to graph first to help us? Sine, right? Okay. So we would first graph y equals 2 times the sine of 2x. Everything stays the same except for we replace cosecant with sine. So we would first graph y equals 2 times the sine of 2x. I know at home there's a lot of lag time today. In order to help us graph y equals 2 times the cosecant of 2x. All right, so let's look at y equals 2 times the sine of 2x. Y equals 2 times the sine at 2x. And what would our amplitude be? 2. Remember, amplitude is the absolute value of A. So in this case, the absolute value of 2 is positive 2. So amplitude is 2. Is our period going to be 2 pi? No, because our coefficient of x is a number other than 1, right? So remember, to find the period, you do 2 pi divided by b. Remember, b is the coefficient of x. So in this case, the coefficient of x is 2. So we would do 2 pi divided by 2, and our period is just pi. So let me go ahead and draw an x and y axis. I know my amplitude is 2. So I need to go up to at least positive 2 and at least down to negative 2. I'm going to positive 3 and negative 3. And my period is pi. I'm going to draw 2 periods. So I'm going to go from 0 to positive pi and 0 to negative pi. It did not say graph 2 periods. It didn't say that, but I'm just going to do it just so we can see more of the graph. And so I have 2 periods here. Remember, when you're graphing sine and cosine, each period you divide into 4 equal sections, right? So I've got 2 periods. So I'm going to have 8 sections, but let me just look from 0 to pi first. So I always like to start by dividing in half. So half of pi is pi half. A quarter of the way through would be pi fourths. 3/4 of the way through would be 3/4 pi. And then on to the other side, it's going to be exactly the same, but negative. So I have negative pi halves, negative pi fourths, and negative 3/4 pi. I'm going to slow down a minute because everyone at home, there's a lot of lag time, and I'm going to let it catch up. But just so you know, I'm going to do a table of values. Even though I know what this graph is going to look like, I'm going to do a table of values to kind of help remind us, jog our memory on solving trig equations. And I'm just going to do from 0 to pi because that's 1 period, and then I know all the negatives. We're just going to repeat the pattern, right? I can do all that in the table of values if I want to, but just do 1 period and repeat the pattern is fine. So, table of values. And I'm graphing y equals 2 times the sine of 2x. And I'm going to also draw in a little unit circle. It's been a while. And my ordered pairs. So 1, 0. So let's start when x is 0. So that's going to be y equals 2 times the sine of 2 times 0. So we're going to do 2 times 0 first, which would be 2 times the sine of 0, right? Then remember, we have to find the sine at 0. What is the sine at 0? 0, because your sine is your y value, right? So that would be 2 times the sine at 0 is 0. 2 times 0 is 0. So we have an ordered pair at 0, 0. Let's find when x is pi fourths. So we have y equals 2 times the sine of 2 times pi fourths. And what is 2 times pi fourths? Pi halves. So y equals 2 times the sine of pi halves. What's the sine of pi halves? 1. So that becomes 2. The sine of pi halves is 1, so we replace sine of pi halves with 1. And 2 times 1 is 2. So when x is pi fourths, y is positive 2. Now I'm going to see when x is pi halves. So we have y equals 2 times the sine of 2 times pi halves. Lag time is awful in this video. My apologies. All right, what is 2 times pi halves? Pi. So 2 times the sine of pi. And what is the sine of pi? 0. So that gives us 2 times 0, which is 0. So when x is pi halves, y is 0. We're back down to the midline. Next, we will do when x is 3/4 pi. So we have y equals 2 times the sine of 2 times 3/4 pi. What is 2 times 3/4 pi? Right, because it's 6/4 pi, which reduces to 3/2 pi, right? 3 pi over 2. So y equals 2 times the sine of 3/2 pi. And what is the sine of 3/2 pi? -1. So that would be 2 times -1, which gives me -2. So at 3/4 pi, when x is 3/4 pi, y is -2. And then all we have now to do is pi, and then we'll just repeat the pattern on the other side of the x-axis. So when x is pi, y equals 2 times the sine of 2 times pi, which is 2 pi. What's the sine of 2 pi? 0. So y equals 2 times 0 gives me 0. When x is pi, y is 0. So remember, I'm only graphing 2 times the sine of 2x right now. I have to use this graph in order to help me graph 2 times the cosecant of 2x, okay? So I haven't done anything to graph 2 times the cosecant of 2x yet. So if you're confused what the left side of your graph is going to look like, then do the math, okay? But we know what the pattern's going to be. When x is negative pi fourths, what's y going to be? Is it going to go up to positive 2 or down to negative 2? Down to negative 2. At negative pi halves, what's y going to be? 0. At negative 3/4 pi, what are we going to have? Positive 2. And at negative pi, what are we going to have? 0. Again, the problem did not tell me that I had to graph 2 periods. I chose to do that just so we could see more of the graph, right? Is everybody cool so far? All right, so once we have graphed the sine function that corresponds to the cosecant function that they asked us to graph, the next thing I would do was sketch in the vertical asymptotes. Remember, wherever my sine graph touched the x-axis, had an x-intercept, that's where the corresponding cosecant graph is going to have an asymptote. So at all of your x-intercepts, just draw in a vertical asymptote wherever you see an x-intercept. Okay. Remember what we just read on the previous page. A maximum point on a sine or cosine curve would be a minimum point on a secant curve. So like this first interval between negative pi and negative pi halves, my sine, this was a maximum point on the sine curve, right? It's going to be a minimum point on the cosecant curve. The next interval is going to be between 0 and negative pi halves. So on that sine curve, the point in the middle, that was a minimum point. It would become a maximum point on the cosecant curve. Where your sine, the y values of your sine, those are not going to be the same as any y values of your cosecant. Okay, they're not going to overlap each other. So like go to the next interval between 0 and pi halves. Would I draw a curve? Would I draw the graph point going up or going down? Up, right? It's not going to have the same y values. The only y value that's going to be the same is that maximum or minimum point. That's it. And then between pi halves and pi, am I going to draw that curve pointing up or pointing down? Down. So 2 periods of the sine function actually gave me 4 periods for the cosecant function, right? So I'm going to make a little point. I used purple. So the purple part is the actual graph of y equals 2 times the cosecant of 2x. That black part is the graph of y equals 2 times the sine of 2x. We just needed it to help us graph the cosecant, okay? I also just want to make a little point when we did those asymptotes. Sketch vertical asymptotes at every x-intercept of the sine function. Okay, so as long as you can graph sine and cosine, you can graph secant and cosecant. So I only intended to give you this one example on cosecant. If we did secant, then we would graph cosine, right? When we're trying to graph cosecant, we have to first graph sine. When we're graphing secant, then we graph cosine, and you just have to memorize that. So do I need to do any other examples, or are you good? The graphs that I'm going to give you are pretty basic. Like we're not doing anything with the vertical shifts up and down and all that kind of stuff. I'm not giving you any with phase shift. They're just going to be pretty basic, okay? The more sine and cosine, that's when I really want you to know, like, you know, more detailed, higher level graphs, but secant, cosecant, tangent, I just want you to know the basics of it. All right. So do we need to do another one, or are y'all good? Okay. So on the assignment, you're going to be doing cosecant and secant. Okay. Got that? And I don't want you to turn it in today. At home you can, because y'all stuff is all organized on the computer. But everybody in class, if you finish today, I don't want you to turn it in today because I have too many papers I got to go through. I don't want to add this to the mix. So I'll take it tomorrow. All right. Anybody have any questions? Okay, so I'm going to stop the video and then I'll write the problems down. I will try to stop the video. And again, if you did not have your work to turn in to me today, you need to bring it to me tomorrow.